Today we're going to be working on 12.3, which includes inscribed angles. Just for visual purposes, the inscribed angle here is angle B, and the intercepted arc is going to be AC. So our first theorem is going to be based off of this. We're going to be looking at this theorem as our basis for the next couple corollaries or other theorems. And it's really important that we focus on the information that's given on this one. So the measure of an inscribed angle is going to be half of the intercepted arc. So I'm going to write that out. The measure of the inscribed angle is half of the intercepted arc. And I should put arc measure. My apologies. Measure. Remember, it's not arc length. We're talking about a measure. Measures are in degrees. So the measure of angle B, that's our inscribed angle. Again, inscribed angle, angle B, will be equal to half of our intercepted arc. So the measure of AC, and it's an arc, so we label it as an arc, and that is right there labeled. And the reason why we call it an intercepted arc, if we were to draw a straight line out, this angle B would intercept that arc AC. Now, based off of that information, we're going to use some context clues. If you notice down on the second theorem, we have two inscribed angles this time, angle A and angle B. And they are going to intercept the same arc. So the two inscribed angles that intercept write it a little bit nicer, intercept the same arc are going to be congruent. So this means angle A, measure of angle A, is the same as the measure of angle B. But let's be a little bit more specific. I'm going to give these points now, point D and point E, and I'm going to highlight, hey, guess what? They share the same arc, so they intercept the same arc. So if I were to extend this out a little bit further, let's use the first theorem again. It's going to be half of the measure of the arc DE. And that's really important. We're going back and making sure that we reflect back on the original theorem. Okay, let's keep on going. An inscribed angle in a semicircle, so in this case angle C is inside of the semicircle, in a semicircle, is a right angle. Has to be a right angle. Again, going back off of this, let's try this. This is going to be E and F. If we look at this arc EF, we notice it's a semicircle, which means that it is 180 degrees. The measure of angle C has to be equal to half of the 180 degree, which means it's got to be 90 degrees. So it always is going to be 90 degrees. Again, it's a semicircle. Angle C, that's our inscribed angle. Let me highlight it. Angle C is our inscribed angle right there. It has to be 90 degrees every single time because the arc across it is 180. Now this one, the opposite angles of quadrilateral inscribed in a circle are going to be supplementary. This one we're going to take a look at in just a moment. What supplementary means is that they equal to 180 degrees. So, for example, the measure of angle B plus the measure of angle D have to equal 180 degrees. Let me highlight that just a smidge. Angle B, this angle right there, and angle D, those have to equal 180. I think this one works better in an example, but what I will show you right here is, if you notice, this is almost a semicircle. It's not going to work out exactly as planned every single time, but this is the premise that we're going to be doing. I'll show you an example in just a moment of why this one works. It's better with an example. Alright, the last corollary of the original theorems is the measure of an angle formed by a tangent and a chord. Tangent and a chord. I might have said that wrong in the previous video, but chord or secant chord, chord is half of the intercepted arc. Is half of the intercepted arc. So in this case, for both examples, we're going to take a look at angle C. So I'm going to highlight it in purple. Here we go. Angle C and this angle C are both going to be the same thing, but the measure of angle C is going to be equal to half of the chord measure of BDC. Half of BDC. This one's a little trickier. Again, this one will work better in an example, but let's work on some examples real quick. So I would say the last two, those two corollaries, are definitely going to be a little tricky. Okay, let's take a look. Let's find the different values in number 1. For number 1, if angle Q is 60, then the arc that it intercepts, PT, has to be double of that. So where I'm using the opposite of this. So A is going to be 2 times the amount of angle Q. It's reverse. If angle Q is half of the measure of the arc, or arc measure, then the angle is going to be, the arc measure is going to be double. So in this case, A is equal to 120 degrees. Now, our only problem with B, angle B, is it's made up of a couple things. Angle B is actually P to T all the way to S. So we have to include multiple arcs here. So it's not just intercepting one arc, it's intercepting 2 of these arcs. So P to T and T to S. So in this case, we have angle B has to be 1/2 of 120 plus 30. So in this case, it's half of 150. And half of 150 is going to get you 75. So angle B is 75 degrees. Angle A is 120. Or sorry, arc measure A is 120. Number 2, if we're looking at this point O is actually the center, and so we are going to look for angle A. But if we're looking at angle A, I already know it's going to be 90 degrees because the arc across from it is a semicircle. So the measure of this arc is 180 degrees, and half of that is going to be 90. So angle A, the measure of angle A, will be equal to half of 180, which is 90 degrees. Okay, we're going to find all 3 sides, or we're going to find all 3 arc or angles. We're going to find angle A, angle B, angle C, and angle D. And like I talked about earlier, is quadrilaterals. If we're doing this right, angle B and angle D are going to equal 180. Angle A and angle C will also equal 180. But there's an easy way to go about this, so let's try it this way. I am going to draw a line. And if you notice, I'm going to highlight this. This arc right here is actually really wonderful because it's going to be 100. The arc length from B to C is 100. Now that's important because that means the smaller part here, this measure is actually 50. Now I'm going to do the same concept for this measure CAD. We look at its arc length, it's going to be 90. And I'm just going to erase this now so you've seen it. CAD. Half of 90 is going to get me 40. So I already know right here, angle A, measure of angle A, will be equal to 90. Now what this forces angle C to be, the measure of angle C must also equal 90, because the two of them combined must equal 180. That was our fourth theorem that we talked about right here. The opposite angles of a quadrilateral inscribed in a circle are supplementary, so they have to be equal to 180 degrees. So in this case, measure of angle A and measure of angle C are both 90. Now B and D are a little bit more complicated, but again, let me show you. BDC, this right here, has an arc length, or BC, that arc length is 100. So if that's the case, this must be 50. If we're looking at the opposite end, BDA, BA, its arc length is 106. We're going to cut that in half. That's going to give us 53. So here's 53 degrees. So angle B, or angle D in this case, measure of angle D has to be 53 plus 50, which is 103 degrees. This forces angle B to be 77 degrees. And let's just verify that. Let's prove that this is true. So I'm going to get rid of everything else so you can see it. I'm going to draw my line from B to D. And we're going to take a look at two different arc measures. So I'm going to go ABD. And we're going to look at the sector, or not the sector, the arc length, arc measure, my apologies, arc measure of AD, which is 64. Half of that's going to be 32 degrees. And now we're going to take a look at the other side, so BDC, which has an intercepting arc length of 90 degrees, which is 45. So half of that's going to be 45. So let's just verify. 32 plus 45 is equal to 77. That's true. So this theorem works out to where we have all four of our angles, A, B, C, and D, but we had to use that theorem which stated opposite angles of the inscribed quadrilateral will be supplementary. So that's really, really nice. Okay, this number 4 is a little bit of a trick. I'm going to highlight some stuff for you guys. This 38 degrees has an arc right here. So this 38 degrees, and I'm going to highlight it, this is 38 degrees. But if you notice, angle 2 shares the same arc. So that comes out to our second theorem, or second corollary of that first theorem. If the two arcs share this, or if the two angles share the same arc or intercept the same arc, that they must be congruent. So measure of angle 2 has to be equal to 38 degrees because they share the same arc. Alright, number 5. We're only finding angle 1. This one is funny because we want to try really, really hard, but what we need to notice first is that this side is actually a semicircle. So we are using the diameter here, which means the arc across from angle 1, across or intercepting, the angle 1 intercepts this arc. That's 180 degrees because it's a semicircle, which forces the measure of angle 1 to be half of that, which is 90 degrees. Okay, last one, finding x and y. Well, first and foremost, J is a tangent point. So this is going to force this to be right here, 90 degrees. So to find y, we don't have to try so hard. Y plus 35 plus 90 has to be equal to 180 degrees. And the reason I say that is because this is a right triangle. So if it's a right triangle, it's always equal to 180 degrees. If you solve this out, you'll end up with y having to be 55 degrees. So y has to be 55 degrees. Now, there's a multitude of ways that we can figure this out, but what I want to show you and what I want to share to you guys is that angle Q right here has an arc right here. And this arc measure from J to L, the measure of J to L is actually 70 degrees because it's double of angle Q. What I want you to notice is that angle J shares the same arc. It's looking at the same arc right here. So angle J, the measure of angle J, has to also be equal to 35 degrees. Which means that X is also 35 degrees. If you don't believe me, that's perfectly fine. We could find another way of doing this, which is what I want you to do as well. It's really important for me that you have multiple ways of solving things. What I'd like you guys to see is that we decided that y is 55 degrees. If that's true, this angle right here, or this arc measure right here, is double that, which is 110 degrees. So if I'm looking on the other side of this, this angle will be half of that, which will be 55 degrees as well. And then we had this 90 degrees. So if you want to solve it another way, the other side of this could be 55 plus 90 plus x has to be equal to 180. And you might ask me why. Well, what I'm really doing is adding up this line, and lines are going to be 180 degrees. So there's this other way to do it, and you could say, hey, this is 145 plus x degrees is equal to 180. Subtract 145 from both sides, so x has to be 35. So there's two different ways of solving it, but you did it with me. Hopefully you caught everything. I would say take your time, go back, watch this once or twice, maybe at 1.5 speed or 2 speed. But if you have any questions, please feel free to reach out. Have a great day.